Okay, we're on the home stretch. We can do this. Number 28 says, let g be a twice differentiable function such that the first derivative is bigger than 0, so positive, meaning increasing, and the second derivative is greater than 0, meaning it's concave up. Okay, meaning the derivative is increasing. Okay, so we have g of 4 is 12, g of 5 is 18. It's saying, what's g of 6? Okay, so we know it has to be increasing, meaning the y values have to be going up because the first derivative is positive. So I have 12 to 18, and the next number has to be increased from 18. So that eliminates a and b. Because a is too small, it's smaller than 18. B is 18, meaning it stayed constant. Well, we didn't stay constant, we increased. Okay, next thing. Between 12 to 18, okay, to get from 12 to 18, we added 6. So this is the rate. All right, so let's try. If the next number is 21, if it's 21, then from 18 to 21, we only added 3. That's less than 6. We don't like that because the second derivative is positive, meaning concave up, meaning we're increasing the rate as well. Okay, so 21 can't be. What about 24? If 24, from 18 to 24, that's going to be plus 6. So that's exactly the same, which means the rate didn't increase. So we don't like that. So the only option we have is 27. So to get from 18 to 27, we have to add 9, which is bigger than 6. Okay, that's why that's the answer. Number 81, it's a calculator section. So you have the first derivative here, sine of x squared plus 1. How many relative extrema does f have on the interval 2 to 4? So I'm focusing between 2 and 4. I'm going to graph f prime of x. So that's my first, second, and then third step, I'm going to find the zeros. And lastly, I'm going to check where f prime changes from positive to negative or from negative to positive. I'm going to count them. So if there's 1, 2, 3, 4, 5, that's what tells you how many relative extrema you have. You can do that. Number 87 says the function f has a first derivative given by this. This is calculator section, so you are correct. You will have to use your calculator. It says, what's the x coordinate of the inflection point? All right. Inflection point is when the second derivative changes from positive to negative or negative to positive. Okay, so there's a few ways you can do that. Do this. Plan A, you can get f double prime of x using your calculator, get the derivative of f prime. Then you can graph f double prime of x, check zeros, and see the change from plus to minus or minus to plus. Okay? That's plan A. Plan B. Either way, you get the same answer. You can graph f prime of x right away. You can find max or min. Then you can just make sure that you get the x coordinate. Okay? And that's your inflection point. So either way, choose whichever one you want to try, then make sure you check with the person beside you that you guys are in agreement of the answer. Number 90. For all x in the closed interval 2 to 5, that means starts at 2, ends at 5. Okay. You have a positive first derivative. So if the first derivative is positive, that means I'm increasing. and the second derivative is negative. That means I'm concave down. Or the slope is decreasing. Okay, let's look at the numbers. So let's see. 4a, I'm going from 7 and 9 to 12 to 16. So great, that's increasing. I like it. Now the change in between them from 7 and 9 is a plus 2. From 9 to 12 is a plus 3. From 12 to 16 is a plus 4. I don't like that because I want the slope or the change to be decreasing. So A doesn't work. Let's look at B. B, the numbers are increasing 7, 11, 14, 16. Great, I like that. And let's look at the slope now. 7 to 11 will give you plus 4. 11 to 14 is plus 3. 14 to 16 is plus 2. I like this, so I'm going to circle it. Let's look at C. 16, 12, 9, 7. Already there's a problem. They are not increasing. 16, 14, 11, 7. Same thing. 16, 13, 10, 7. Same thing. They're decreasing. So the answer has to be B. For the free response 2013, number 1 and number 4, make sure you pick up a copy of the solution with the scoring guidelines so you can see exactly the breakdown of the score and how to answer those two problems. They're good practice. Last one. Okay, this one uses the theorems. I just want to give you a preview. I have a table. Okay, you have x values 1, 2, 3, 4. You have f of x, you have f prime of x, you have g of x, and g prime of x. Okay, so it says the functions f and g are differentiable for all numbers. G is strictly increasing, meaning g is always going up, increasing. The table above gives values of the functions and their first derivatives at selected values of x. The function h is given by h of x equals f of g of x minus 6. Okay, let's focus on A. A says, explain why there must be a value r, so some sort of number, between 1 and 3, for r 1 and 3, such that h of r equals negative 5. It's saying, show me why somewhere between 1 and 3, h of r has to equal 5, negative 5. So let's start with, focusing from x equals 1 to x equals 3. So now let's look at h of 1. If I do h of 1, that means f of g of 1 minus 6. So all I did was take 1 and I plug it in for x. You can do this. Start from the inside going out, okay? G of 1. Let's look at g, 1, that's 2. So I have f of 2 minus 6. What's f of 2? Let's go to 2. F, it's 9. 9 minus 6 is 3. Okay, so h of 1 should be 3. Now let's try h of 3. So that's f of g of 3 minus 6. G of 3, go to g, 3, that's 4. F of 4, go to f, 4, that's negative 1. I have negative 7. So it's saying somewhere in between 3, h of 1, which is 3, and h of 3, which is 7, is it possible that we have a y value that's negative 5? Yes, it is. Okay, think about it. Negative 5, so if I made a number line, negative 7 is here, 3 is here. Negative 5 is somewhere in between them. Okay, so if I had a graph that had 1.1 comma 3, so this point is 1 comma 3, and I had 3 comma negative 7, so let's say 3 comma negative 7. Somewhere in between, since it's a continuous graph, I have to hit negative 5. Let's pretend negative 5 is right there. I have to hit negative 5. Okay, so you're going to say by it's one of the theorems, so it's either extreme value theorem, mean value theorem, or intermediate value theorem. This one is the intermediate value theorem. Okay, there exists h of r equals -5 because -5 is in between h of 1 and h of 3. That's all it's saying. It's saying, show me why there has to be an x value in between them, that the y value is -5, and you just did it. Great. Now let's look at B, okay? Explain why there must be a value c between 1 and 3 again, such that the derivative, okay, the derivative this time is -5. So it's not just a regular numbers, it's once a derivative. Okay, I'm going to give you an idea. This has to use the mean value theorem. Okay, this has to use the mean value theorem.